Hi everyone, today we are going to talk about Helm, the package manager for Kubernetes. It allows you to deploy very easily third-party tools, but also to create and template your own services and applications. In this video, we are going to talk about what is Helm, how it works, and even demo how you can create your own Helm chart using Helm. Day number 11 of 30 days of CNCF projects. Let's go. Helm is a package manager for Kubernetes, like Brew for Mac and also apt and yum for Linux, npm from Node, pip for Python, any kind of the package managers that you ever met. Helm is the package manager for Kubernetes that allows you to deploy packages very, very easily. In Helm, we do not call them packages, we call them charts, and each chart generates the manifest to run the application or the package that we want to deploy. So basically, it can help you to deploy very simple applications like one deployment with one service YAML, but it can also make a huge deployment and deploy, 10, 15, and even 100 manifest using the chart. So chart can vary in the size and what they're capable to deploy. How do we deploy Helm package? So there are like two variations of repositories. We can deploy them from local, something that we do when we developed our own, and we can also create an artifact, a package, and put it on a Helm repositories. And then when someone tries to install it, it installs it from remote. Something that is very unique about Helm is that the target is to generate manifest, but it allows users to change and adjust the manifest based on their own parameters. So let's say that we have a package and we want to control something about it. Let's say a service, if we want to deploy it with a local IP service, or we want to deploy it with an external load balancer. So Helm allows the user that deploy the chart to control that using values populated by the owner of the chart, and the chart will template and generate the manifest based on the user provided values and parameters. So most of the package manager, you just deploy the package and everything just comes very closed. In Helm, you have the ability to control the values and what's going to be deployed. So how Helm works in one sentence, you get the chart from local or remote repository, you provide the values that you want to put in, Helm will generate the templates or generate the manifest from the templates and deploy them into the cluster and leave some traces so you can follow them and track them over time. Each Helm chart got version, like any other versioning, and also dependencies to deploy multiple charts together when one got dependencies to the other. Let's talk a little bit about the main use cases of Helm and understand them a little bit better. Why you should use Helm? So it got two main use cases. The first one is to deploy third-party applications or open source project. When we want to install an operator on our clusters like Argo CD, or we do want to use a SaaS product and we need to install agent on our clusters, the easiest way for them to pack the application or the agent and actually ship it to us and for us to install and deploy it is using Helm. So open source project and also vendors prefer to pack anything within a Helm chart. So we are, as the users, will be able to install them very, very quickly and easily. If you watch the previous demo of this series, you already saw me installing almost all of the project using Helm. It makes it very easy to deploy, and I can adjust and change what is provided for me because the vendors create those values that allows me to change and adjust the package based on how I want it to behave. The next use case is to pack and deploy our own services. Something that is very common is that we have one way to deploy all of our application and services across our clusters. We can create some manifest in each one of our microservices repos. We can separate the repo to be an app repo and also deploy repo for each microservice. But in fact, when we need to scale those, we want to have an easy way to create a template and then use it to deploy all of our other services. So Helm can be used to deploy your own services using a single template. What does it mean is that as a platform engineer or a DevOps team, you can create one skeleton of how application looks in your own organization, and based on the values of each microservices, adjust it and deploy it to your own clusters. This is less common use. So when we are talking about what is common or less common, the most common use case would be deploy third-party application or services. We see that everywhere, and less common is to deploy our own services because there are wide varieties of templating tool and also deploy tools. We said that Helm is not only a package manager, but it also got templating capabilities. Why is that so important and crucial when we deploy applications on Kubernetes? When we take a look on a regular package manager like Brew, what it does, it basically got some binaries that needs to be put on the right path on your machine. And it's also got maybe some script to discover some things and put it on the right path. And that's it, the package is installed. But when we are talking about deploying into Kubernetes, running our application is not that simple because we need to generate manifest. And when we deploy our applications or a third-party application, we need to control it somehow. For example, how do we want the service to behave? Should it be load balancer, external load balancer? Should it be like internal IP? Should it have HPA or not have HPA? Should we deploy it on highly available architecture or not? And so Helm allows you to have and give the user the control using those values and parameters, but at the backend, it's need to generate the manifest based on that. So for example, if we picked a load balancer service instead of cluster IP load balancer, the template should behave accordingly. And if we decided to deploy Argo CD in HA mode, we need to deploy Argo CD on the backend in HA mode, which requires to have some specific configuration behind the scenes. So Helm allows you also to do the templating for that, and this is why it's so important. So how does it work? Each chart got values. Values is the configuration that allows you to control Helm, and in the manifest themselves, you will find a templating language that allows you to control how the manifests are going to be generated. Let's take a look at an example on a values file, which got a lot of parameters and we can adjust, control, and change them. And now take a look a little bit on values on the manifest and see that we have some places we can adjust, change. Obviously, when we develop a chart, we need to understand the templating language. And when we're using it, we basically would go into the values, and each chart got a README file with all the values and what you can do with them. And this is how we would use Helm. We can provide values to the Helm chart in three ways. One, it got like the default values. Those are the ones that you would see installed by default when you install the chart without having or changing any parameters. We do have a way to supply user values in two ways. One, we can add them into the command line when we do Helm install or Helm upgrade. We can set the values and change them based on how we want the third party or the package to behave. And we also got the third capability, which is also user provided values, but we can create our own file and use the values in the file. So it will be, we will use in the command that we put in, we will reference to a file and the file will get all the values. So if we need to change one or two parameters, we may do it inline using the command line. But if we have a complex values configuration, we will do that using a file that we can save in Git, and that will be the easiest way to maintain that. So that sounds like a dream, right? Because we take the package, we just deploy them, and everything just works. It got some downsides. So when we use Helm and when we use a chart, it's very, very easy because someone take care for the templating and all the things behind the scenes. But when we need to maintain the chart. It can make it a little bit complex, long, and the templating, as you may guess, can be very, very complex because you need to support a lot of functionalities, a lot of permutation of how the service and application should behave, and the templating can become a little bit complex when you need to scale it and support various of use cases with your own chart. I want to show you very briefly how can I take a look on Argo CD Helm chart on a website called Artifacts Hub that got a lot of artifacts that you can use, and explain how you can understand how to use that. So when we take a look on the website, we have the Argo CD here, we have the README file of the Helm chart with all the explanation about it, and we can also click on it and move into GitHub if we want to. On the right side, we have a few buttons that we can click. The first one is to install, and then we would get the installation of this Helm chart. It allows us to add a repository, meaning we are going to add Argo CD repository into our own Helm local client, and also to deploy and install the chart using the command. The command will use only the default value, as you can see it in here. If you want to change and understand what are the values and what you can do with them, you can click on the default values, and here you will see all of the values and how you can change and adjust them. They are search, download, everything in here is very easy to use and consume. We got the template section. In the template section, you will be able to see all the manifests that are going to be generated when you are going to install this chart. Not all of them will be generated in each one of the values we'll provide, but you can see we got like 116 of them. A lot of manifests that are going to be generated and deployed when you're going to use this command. But you will see maybe that some of them will duplicate, and maybe in specific values, some of them will be omitted. So it doesn't mean that anytime you would do Helm install Argo CD, all of the 116 will be deployed on your cluster. We also got a changelog if you want to compare them. And if we are going and taking a look on the Argo CD GitHub repo and we're scrolling down a little bit, we can check and see all of the values there too, which is very useful for us. Helm works in a client-server architecture, meaning that in order to deploy Helm chart, you need to have Helm CLI. It can be on your laptop or your own machine, but also when you deploy to production, you may have a Docker container with Helm binary installed in it to do the deployment. When you're using CI or CD tool, they usually got Helm installed in them to help you to do that. So on the client machine, we need the Helm CLI. The next thing is that we need a remote repository that will hold the chart. When we are using third-party tools, the chart will be available on the repository. What we need to do is that we need to add the repository to our client so it will know to search for the chart in the repository when we need it. And then when we do Helm install or Helm upgrade -- install, Helm client will go into the repository and first of all will fetch the chart. The chart will be stored in the repository. A repository is just a basic website that got all the files. Once the chart downloaded into the client, we also provided in the Helm install upgrade command the values that we want the chart to be installed with. And now Helm will generate the manifest based on the chart downloaded and also the default values in the chart that is downloaded, but also being overridden using the user values that we provided using the command or the file we provided in the command. And then Helm will do the templating work. And after that, when the manifests are ready and correct, Helm will deploy the manifest into the remote and destination cluster. And that's it. So the installation is done, the chart is being deployed, all the manifests are generated. Helm got some capabilities if we want to use some wait and timeout, if we want to make sure that all of the resources were created successfully. At the end of the installation of the deployment, Helm client will keep the details and the state of the installation of the chart in a secret on the same namespace. So because it's a client-server architecture, when another client will try to understand which chart installed on that namespace, the state needs to be kept in some place that is accessible for both. And this is why the client that does the installation will keep the state information in a secret on the namespace, and the next client will be able to fetch this information. And this is how end-to-end installation flow of an Helm chart works. Helm got a really good alternatives out there. But the main thing is that Helm got two main capabilities, and we need to distinguish between two of them to understand which alternatives are relevant. So the first capability is the versioning and the packaging, the way that allows us to create a package artifact and deploy it on our clusters. The second capability is the templating. Unfortunately, both of them are actually tied together when we are talking about Helm, but when we are looking for alternative, we need to understand if we are looking for alternative for only one or both of them. So there are main alternatives, and I think that most people, when they're trying to find out what would be a good alternative for Helm, they're looking for the templating. So indeed, for the packaging, Helm is kind of the de facto standard out there for packaging and deploying third-party tools in a way that allows to package the artifact and deploy it into your clusters. When we are talking about templating, there are many language and templating tools that will allow you to template your own manifest, create like this skeleton or template for your own services, and then deploy it and override it multiple times. Customize is one of the most common out there when we are talking about Kubernetes, but also got Tanka, which is a JSON-based option, or CDK, usually used using JavaScript or Gravel, or there are many tools out there for doing Kubernetes manifest templating. If you're looking for a solution only for the templating, you can consider Helm or the other, but if you're looking for a tool for both of them, Helm should be the go-to for you. In the demo today, we are going to see two main things. One is how to deploy a third-party tool using Helm. It's going to look something very similar to what you already saw in previous videos, but we are going to break it down step by step how it's going to look when I'm going to use a simple command. I'm going to explain the full flow. The second phase of the demo will be how do we deploy Helm using a local chart. So I'm going to show you how you can create your own chart and basically deploy and create your own Helm templates and charts using it. So let's start with the first step. So for the first step, we are going to use the repo we are using for all of the demos, Guy Menachem How to DevOps Tools. We do get the Helm section, and we are going to deploy Argo CD. So on the left side, I got a kind cluster already ready to use. And what I'm going to do for the first step is to add Helm repo to my chart. So the Helm CLI is already installed. I can do Helm help and I will get the help context I need. The second part will be Helm repo add Argo CD, and we are going to use Argo CD repo for that. So what's going to happen is that Helm repo will be added to the repository. We can do Helm repo list and see all of the repository. I got a lot of them, so I will grab Argo, and you can see that Argo is the new repository we just added, and this is the repo location. Cool. Helm repo update will fetch the structure of the repo to our local. Basically, it allows you to see and list the versions locally. It will go to all the repositories installed locally on your Helm client and will fetch the information from them. It will not install anything at this moment. So now we have added the repo to our client, and we also added and updated the local information about the remote repos. Now we can check which versions available through the repo. So we are going to use Helm search repo argo -- versions, and that will show us all of the versions available on the remote repositories. So what you can see in here, I will maybe grab it to make it a little bit easier to see. Okay, so we got in here the name of the chart, the version of the Helm chart, the version of the application. So Helm got like two versions. One is the version of the chart and the version of the application. Sometimes one of them will be updated without the other. You can see in here, for example, that the chart changed from version of the Argo application, the application set changed from one version 1.12.0 to 1.12.1, although the application did not change during that time. So it's not necessary that one version will be updated alongside the other, but you can control those, and there is like at the end a string that allows us to understand what this chart is. So you can always run the command Helm search repo for the versions, and then understand if there are new versions for the application on the chart you're trying to do. When you're using with latest and you got some CD tool that's trying always to go with the latest, it will do that and then will install the last version. Okay. Next part is that we want to review the Kubernetes manifest that will be created using the chart. So for that, we are going to use a command called Helm Template. Helm Template basically allows you to generate the manifest, but not deploy them into the cluster. So it's like a review that we can do before we are actually deploying. This is a really useful command when you are trying to understand like what is this chart going to install into your clusters. For example, you are afraid that the RBAC this application got is too intrusive for you. So you would do that, and when you develop, this can be a very useful command. So I'm going to do that, and I'm going to pipe it to less so it will be easier for us to see the output. And it runs, now it fetches the chart from the remote repository, generate the manifest based on the values. And here you can see the values and what is the source that generate this specific YAML and what is the YAML just got generated. What you can see is that any YAML that got generated by Helm will get this label, allow you to understand what is the chart and what is the version of the chart. So it's easy for you to understand if a YAML manifest or resource created on your cluster, what originally made them to be created. Cool, and we got all of the manifests in here. You can see a lot of them like service account, secrets. I guess this is the secret of the password for the Argo CD notifications. You can see all of them in here. Config map for Redis health config map. Whatever, everything is available. And if you would change the values provided to the Helm template, you will be able to see the change actually taking place in the chart or the manifest being created. Cool, so now that we understand how Helm template works, what we can do next is to try to deploy. So we are going to use Helm install, but we are going to do that with a dry run flag. A dry run will actually generate the manifest, validate them against Kubernetes API, but will not create the resources. So we can run that. And what you will see in here is a very long output, but it's a really good output. If we will scroll up a little bit, so I will clear and run it once again, so it will be easier to see. Okay, so what we can see is all the manifest being generated in here, like we saw before, right? Like all the YAMLs. But if we scroll down, we will see the notes. Notes meaning that, first of all, everything is done, installed or dry run installed successfully. And there are notes for any Helm installation, allows you to understand how to use it. In here, for example, if you want to access Argo CD UI, you have instruction how to do port forward, how to enable ingress if you want to. You can also do that using the values file or to do that manually. How to get the initial Argo CD password on a lot of nodes that can be useful for you right after you've done the installation. I will also echo for the return code, making sure that everything is done successfully as dry run and we get the 0, which is great. Cool. So now that we understand, first of all, how the template looks like and the dry run went successfully, we can deploy Argo CD using the same command. There are two variations to do the installation. One is the install command, which you can see in here. Helm install will install that. The problem with Helm install is that if you are doing double installation, meaning you're going to install the same twice, you need to specify that. So something that we can use is Helm upgrade -- install, and I'm going to deploy Argo CD. We are going to deploy it. So this is the name of the chart going to be deployed. This is the repository looking for the chart. This is the name of the chart. We are going to deploy it to the Argo CD namespace. We are going to create a namespace named Argo CD if it's not exist. And also we are setting a few values for the Argo CD server admin password if we want to have initial password. And we also change the password creation time. Cool, so release Argo CD does not exist, installing it now. Now it's going to deploy, generate and deploy all the manifest. And when we get the notes back into the terminal, we will be able to understand that everything is fine. So let's wait, it can take a few seconds. And now that we see that everything actually deployed, we can see that release installing it now. The name of the chart, when it was last deployed, namespace status, meaning that everything went successfully. The notes as we saw before, and all the notes in here. So everything installed successfully. If we would do kubectl get pods on the Argo CD namespace, we will see that all of the pods of the Argo CD are now running or completed, so everything is healthy. And now we want to check the Helm status. So what we will do is that we will do Helm list on the namespace Argo CD. And we can see that we have one chart installed. It deployed successfully. I will maybe increase that a little bit to make it easier to read. So everything is deployed successfully, and now we got Argo CD deployed on our cluster. If you want, you can connect into the Argo CD UI and also make sure that everything works great. So we will use this command, and it will open the terminal for us. It can take a few seconds. You need to approve that it's unsafe. Because we provided the password using the values file, which is great. You can use the admin. And now you're in. Argo CD is deployed successfully on your cluster. And this is how easy it is to deploy third-party applications on your clusters using Helm. And in this demo, we did that step by step. I want to show you how easy it is to deploy third-party Helm packages using Argo CD and why Helm make it much, much easier. So what we're going to do, we are going to use the Argo CD UI and to create an application in Argo CD. So the application we are going to create called sealed secrets on the project name default, and we are going to make it automatically synced. And now we need to pick our repository URL. So we are going to the repo, the How to DevOps repo, and we got the repo to install sealed secrets. So we are going to take the repo URL and we are going to paste it in it. And on the right side, we are going to change it to be Helm. And now it's going to list all of the charts available. And we are going to pick sealed secrets. And we can also pick the version. So we are going to use the latest one. And for the cluster URL, we are going to use the local one. Kubernetes default SVC is the local cluster Argo CD installed on. And I'm going to use the default namespace just for the demo. Cool, and that's it. At the bottom, we can see all of the values file, and the values themselves, and all the values available in the chart listed in here. We are going to click on Create. And what's going to happen is that you can see in here that Argo CD created a new Argo CD application, sealed secret using a Helm. And if we get into it, those are all the manifests generated using the Helm chart. So Argo CD and Helm really comes together. Something that we need to notice when we deploy a Helm chart using Argo CD, it actually generates the manifest, but it will not use Helm as a client. So you will not have the Helm secret, so you will not be able to list it as an Helm chart if you would use Helm list. So it works a little bit different. Argo CD mainly generate the manifest, but not use all of the Helm flow as we saw before. What we are going to see next is how we can create our own Helm chart. The last part of the demo is how do we create our own Helm chart. So first of all, when we got the Helm client, we can run the Helm create command, and that will spin up a directory, like a bootstrap directory, with all of the files needed for us to create and pack our chart. If you clone the AutoDevOps repo, you got the Helm section in it, you will be able to see a directory called chart and a basic chart called basic service. You can see a few files generated in here. One is the chart YAML. This is the configuration description of the chart, API version, the name of the chart, description of the chart, type, version, and app version, as we saw before when we list the remote repository. We also got the values file with a lot of values. In here, we got a few basic values like auto-scaling, service. I removed most of them, replica count, image, etc., etc. Helm ignore, and the templates. And the templates are the actually manifest. In here, I removed most of the out-of-the-box manifest generated, but you can see near the deployment. And here, for example, the name of the deployment will be taken from the values file as full name. Or the labels will also taken from the values. So from the name of the, like from the label created by the chart, but also the values. So this is a reference for general names or general variables within the chart, but those are referenced to values, for example, the replica count. So the replicas will be created based on the replica count, and the service will be created based on the service generated in here, the port we picked as in the values, etc., etc. So that allows us to create a template of our own application. It can be basic one as this one, or more advanced if you decided to make it a little bit more complex. So when we are going to do the Helm template works the same, but we are going to reference a local directory called .chart/basic service. Let's deploy it, and what you would see will be generated is the service YAML, right, with all the labels as I mentioned before. Ports are default, and replicas, let's check that, will be 1. This is really good and a basic use of that, and now we can check that everything is fine. By the way, I can also do, I think, set, and now I need to check the value out of my values. I think it's replica count equals 3, and let's see if it got any effect. And if I would go into the replicas, that will generate the same one effect, but now I got 3 pods into my deployment. So this is how easy it is to change values and adjust them when you create the templates and also deploy Helm charts. And the last part of the flow would be to do Helm install. So I'm going to install it, but I'm going to obviously change the replica count to 3. And I'm going, for example, to create a new namespace and deploy it into that namespace. And now files are generated. You can see in here the nodes. And when I'm going to do kubectl get pods into my app, you can see that we have 3 pods running and not 1. But if we would do Helm upgrade -- install, meaning we are going to update the current chart installation with new values or with new configurations. I'm going to change it to 1. Now a new manifest going to be generated with replica equals to 1 and also going to be deployed. Now the revision in 2, meaning a new version is being deployed. And if we will do get pods, we will see that only 1 replica is running. By the way, if we would use the Helm install command with the replica count equals 3, it failed because it cannot reuse a name that is still in use. This is why we need to do the Helm upgrade -- install to say like override the previous chart with the new version. And that's it for the demo today. We saw how do we deploy Argo CD step by step using Helm, how do we deploy Helm chart or Helm package in Argo CD, and also how to create our own Helm chart using local repositories. And the last part of today is the sticker. Day number 11. That's it. Thank you very much. See you next time.